morning once again, colleagues. I am honored to present you the next presenter, that is Mr. Yaya Nyassi. Yaya is working with the Department of Forestry as a GIS and forestry survey specialist. Yaya have undergone series of training, which includes a HND in development studies. He also did a diploma in community development, a certification in applied forestry, which coupled with his WAS certification that he attained at Kodu Senior Secondary School. Yaya also has a BSc in development studies at the University of the Gambia, which is one of his most recent educational achievements. Just to mention a few of the things Yaya has specialization in includes conducting forest monitoring using GIS tools as per his responsibility at his working place. He also do mapping community forestry and government forest parks. He also analyze survey data and train field staffs in GIS application. I think as shown in his CV, I have engaged in so many activities and projects within his workplace, one of which is support staff with the EBA project that was from 2018 to 2024, which is a 6-year time span. He also served as a national consultant for ICRFA, which was between 2022 and 2023. Some of his affiliations are with the Ministry of Environment, Climate Change and Natural Resources, the West Coast Region Football Association, that is Yaya is also into sports, as we can see. So basically this is Yaya, and Yaya, welcome on stage.
Okay, thank you very much, Juma, for the introduction. And once again, good morning, ladies and gentlemen. Like he said, I am Yaya F. Nyassi, and I'm going to continue the presentation from where I stopped again. I will take you through the rest of the presentation. And basically, I will start from basically some of the basic information that that are very important with regards to remote sensing. And first, we will start with the fundamental understanding with regards to optical and radar remote sensing. This is very important because getting the basic information or understanding of how GIS works actually helps you in carrying out further responsibilities with regards to using GIS. So here, our understanding of how optical and radar remote sensing work here, the diagram here shows a kind of, the first picture here shows something like a small cone, and this is an indication of the first part here of this diagram here. It's an indication of how the relationship between the sunlight and the satellite, that is optical, the optical satellite. It indicates how satellites interact with the light from the sun. And the first part here, it shows you can see the bands, they are very close in the first part of the wavelength. And here, this is indicating, where you see the colors here, is indicating that this is the visible part of the sunlight. This is the visible part of the sunlight. This is the part of the sunlight that we can see with our naked eye. You understand? But before then, here you have this area where you see the gray color, and after here, these are areas where we cannot see with our naked eye. What this interprets is sunlight has so much to play with regards to when it comes to optical remote sensing. That because the optical satellite they actually rely on what is reflected from the sunlight. So, but if you look at this diagram here, the visible part, you can see the bands are they occur very frequently. But as you move along the wavelength, they begin to, the occurrences begin to separate. That is, it becomes less frequent. So this is an indication that here, where you have more, where the bands are occurring more frequent, these are the areas where the portions where you can actually see the portions where the sunlight is seen visibly by our naked eyes. Let's move to the next. So here, this picture actually explains everything with regards to the radar satellite data collection mode, because this is a satellite that cannot produce its own light, and therefore it relies on the light that is produced by the sun. But it's very important to understand that it does not actually it does not absorb this sunlight directly from the sun. Instead, it absorbs the reflected solar radiation. That is what is absorbed. And it's important also to note when the sunlight comes to the earth, different objects absorb and reflect light differently. So you can see here, this is a forest showing you vegetation. So it indicates that even vegetation as it is, when sunlight comes, they absorb and then also reflect. So the water also does the same, grasses also, soil, and other things, even including buildings. So each of these absorb and also reflect solar radiation. So the reflectance, the reflection, what they reflect is what actually the optical satellite actually absorbs and does its work. So this is an indication that without this reflection, the optical satellite can't do its work. And it is also important to understand that different objects on the earth also reflects solar from this light from the sun in different ways. We will see details in this regards. So this here diagram here is the spectral signature, and the spectral signature actually is like I said, every object on earth has its own way of reflecting light. That is different, unique way, different from the others. So we are looking at three very important objects. That is, we are looking at how vegetation reflect light and how water and soil reflect light. So the spectral signature is a unique way, just like human, each of us here has his own signature. That is a unique way of how you can, actually, every individual has his own signature. So this also, the spectral signature is also a unique way in which each of these transmit or reflect light to the atmosphere. So like the first one, you can say, for instance, the vegetation, that is the spectral signature of the vegetation. You can see how it moves. It indicates that for vegetation, it is lowest at the visible area. It is where you have its lowest when reflecting light, but it has its highest at the near infrared area. That is its signature. That is how vegetation reflects light to the atmosphere. On the other hand, water has a different way of reflecting light to the atmosphere, and that is what gives it its own spectral signature. And that is, for water, it's kind of, most of its reflectance is within the visible area, and actually it goes a little bit up, then it drops down. That is also water's unique way of reflecting the solar radiation to the atmosphere. And the same thing happens to the bare soil, that is soil. Soil also, at some point within the visible area, it kind of increased towards the near infrared and moves a little bit higher in the intermediate infrared. That is also the unique way in which soil also transmit the light that they receive from the sun to the atmosphere. And through this spectral signature, this is how the optical satellite also understands that this is from vegetation, this is from soil, this is from water. Because each of them has a unique signature, a spectral signature. So now here, this diagram gives us an understanding on why do we see vegetation as green? This diagram helps us understand. Like I said before, vegetation, like any other object on Earth, they also absorb sunlight, light from the sun. But for vegetation, when it absorbs light from the sun, including the infrared and the visible, it transmit or reflects. When it is reflecting, it reflects in green, only the green. Even though it receives red and blue, but when it is reflecting, it reflects the green part of it. And that is why when the satellite also captures the radiation that is coming from vegetation, it captures it in green. So that is why when you are interpreting data from the optical satellite, for vegetation, you see it in green, because that is, vegetation actually reflects the radiation in green. So that is the definition. So now let's look at what are some of the differences between the optical satellite and the radar. They are very easy. First, the ability to produce light. That is, the radar has its own ability of producing its own light. And that is why the radar can operate even during the night. Okay? Because it has the ability to produce its own light. But when we say the optical satellite, on the other hand, don't have the ability to produce its own light. And therefore, it relies only on what is reflected from the sun. The sunlight that is reflected. So in that case, that is one of the differences. The second difference is the ability to, so the first one is the ability to penetrate clouds and tree canopies. That is, the radar has that ability. As much as it has the ability to produce its own light, that gives it the ability also to penetrate through clouds, because these satellites are up, and between where satellites are and the earth, we have clouds, and sometimes clouds can kind of be like a barrier between the satellite and the soil. So when the satellites are taking their imagery, clouds can actually be a barrier. So, but the difference is the radar has an ability where it can penetrate even there is cloud cover, and even go further, even the canopy of trees it can penetrate through. But the optical satellite don't have that ability. And the third one is the quantity of bands. The optical satellite actually has more bands, like I showed you in the other picture, more bands, especially at the visible area. You have more bands there. But radar has very less bands. And the third one, data interpretation. So that is where the optical has an advantage over the radar, because the information that is picked by the optical satellite is quite easier to interpret than what is the information of the radar. So those are the few differences, not limited to. So now we move to the other part of the presentation, that is the supervised classification using Landsat and SRMT in Google Earth Engine. So this gives us an understanding of, this particular diagram helps us understand how Google Earth Engine does its work, and CPAL also. It will also help us understand these two. So first, for looking at the two, like I explained, between the radar and the optical satellite here, Landsat 8 is actually the optical. So with it, because it is going to pick satellite images on the Earth, and sometimes these images can be blocked by clouds, it does what we call filtering and cloud and shadow masking. That is the only way it can, that is a way that will help you, at least, even though there are some of the satellite images that are picked by Landsat 8 are affected by clouds. By filtering and cloud and shadow masking, it gives us the ability to at least have options to have clear images during this as a result of this practice. But this one, on the other hand, the SRNT, which is the radar, actually gives the elevation, and because of this elevation is what helps us understand or know the tree heights, even using the Google Earth Engine, because this one does that. So the combination of these two is what gives you can see. This one will give you, the composite, that is with the bands and the spectral indices, and then radar will add elevation to it, so that you can now see all the colors, and at the same time you can know the various heights and other measurements that are very required in. So these are the things that actually these two satellites does. So, and again, in Google Earth Engine, like we said, you have to also, training data is generated, and this is how it is it is always stratified random. The points are stratified. They are, you know, they are, most of the points that are generated, 70% of it is used for training. The machine uses it for training, and then 30% are used for testing to see whether, you know, actually what you want, the objective that you want to, can be achieved, or there is less, you know, inaccuracy. So that is what this diagram is all about. When 70% of the points are tested, are used for training, 30% are used for testing. That way you are able to know your accuracy, how accurate the machine is. So actually this is how it works. Let's go into the details now. So now, how do we use supervised classification in Google Earth Engine to generate mangrove maps? So the assignment is for us to use Google Earth Engine and then generate a mangrove map of our own, choosing an area of interest of our own from what was given. So what was given was the whole country. So, but we are required to go into, use that data, choose a specific area of interest, and then produce a mangrove map and do some analysis with that map. So this is how I did it, because the codes are already there in the platform. But the codes that are there, remember, these are codes for the whole country. So now, how do you specify this code to make sure that you have a specific area of interest? We make the best use of AI. That is, in this case, I use ChatGPT. So in ChatGPT, when you take a photo of this and paste it, copy this photo, paste it in ChatGPT, and ask ChatGPT, okay, I want to edit this code to only include one region and exclude the rest of the region. When you put this picture in ChatGPT, it will immediately show you the steps. That is, if you want, that is one way. If you want, you can go inside there and do the editing. But you know, the editing, sometimes if you edit the wrong place, it will give you the wrong results. So to be on the safer side, what I did was I just took the screenshot of this, pasted it in ChatGPT, and asked ChatGPT that, okay, I want this code to be only one region and exclude the rest of the region. Then ChatGPT would tell you the steps, and in fact, it would give you another code that if you use this code, you will have exactly what you are looking for. So that is what I did. And then when you plot that code from ChatGPT and paste it, by the way, when you are using the code that ChatGPT is giving you, it means you will have to clear entirely. There's a specific area that you need to delete and replace it with the code that ChatGPT is doing. And that also you have to be careful, because you have to know where to start and where to end. Otherwise, if you go beyond where you should delete, you can have the wrong results also. So when you do that, it gives you. So for me, I chose Kerewan as the area of interest. So that is why when I plotted it, it gave me this. And this is Kerewan, not Bank. So when you plot it, this is what I did, and it gives me this. This other map here is showing you, this is the mangrove area from the project that I am working on, but this is the mangrove area with that Global Mangrove Watch. Because remember, Google Earth Engine will also give you an option so that you can know whether you are accurate or not, by giving you the data that Global Mangrove Watch has already. So if you plot your own data and realize that, okay, your mangrove area stopped only here, and you check Global Mangrove Watch, it shows you that, okay, mangroves went as far as up to the end. You realize that maybe I am wrong, because the difference should not be very far. That is why they give you this option, so that you can also compare what you have and what Global Mangrove Watch has. If it is not very different, then you know that you are okay. But if it is very different, you know that there's something wrong somewhere. So this is the one I generated. This is when I checked for Global Mangrove Watch. And you can see there is not much significant difference. You can see. So now, when you have your area of interest, the other question was, you have to now go into the area of interest, and these are some of the things that we are asked to look in for. So for Not Bank, because mine is Not Bank, that is this one. So now what we are going to look for is the number of samples, and the mangrove extent, and the canopy height, and the above ground biomass for Not Bank region. You know, we did that. The other one we did was for the whole country. But now we are, the assignment is you choose your own area of interest and use Google Earth Engine to know all this data. So when I did that for the plots, for the training data, for the plots, for the region that I have, that is not bank region, the training data that the machine allocated was 77, and the testing data was 26, out of a total number of 103 samples. But for that is the extent, the mangrove extent, comparing what Global Mangrove Watch has and what I have, my project have, you can see the Global Mangrove Watch mangrove extent is 393 kilometers square, and what I have is 309 square kilometers. So there is no much difference. I am comfortable that this is okay. And for the canopy height and the biomass, you can see when you click on Inspector, it will show you this detail, but these details that you are looking for. And here I'm interested in, that is the maximum canopy height, which is like 5 meters at least. And okay, this is the mangrove extent. So those are the information. This is the mangrove above ground biomass, that is 37. The above ground biomass is 37. So this tells you that with Google Earth Engine, you can do all this. But I doubt whether with SIPL you'll be able to do this. SIPL will be able to give you this more details. But Google Earth Engine can give you all this detail. Okay? Which I can say is an advantage. So now let's look at SIPL. Like I said, it's similar, but there are some differences. So for SIPL, what we are asked to do here is to generate and classify a Sentinel-2 mosaic in SIPL. That is, you are expected to do something very similar, but now you are going to use a different platform. And for SIPL, what you need to do first is you need to have a project in there. So if you don't have a project, you have to create a project. And to create a project, this is what you do. You name your project, and then you use your project and then create a mosaic, just like the second slide here you can see. Up there is my project. I named it as Nyassi. Then I used that project to create a mosaic using the optical mosaic. Because for SIPL first, you have to create an optical mosaic first before you use that optical mosaic to do your classification. So this is how you create your optical mosaic. You click on optical mosaic, and in this case, we are asked to, when you click on it, it will prompt you to choose an area of interest. And in this case, the Gambia has to be an area of interest. Then within the Gambia, it will ask you which region. If you are interested in a specific region, then you can choose. I choose LRR in that case. That is area of interest in that picture there. So now when you choose LRR, this is LRR. That is the recipe for LRR. The date, you make sure that you choose a date for it. Then the assignment is, instead of the default lands at 8 and 9, but the assignment is asking us to use Sentinel-2. So you have to choose Sentinel-2, and then you choose the bands. So to summarize, when you finish your optical mosaic, fix everything, all the dates are okay and the bands are okay, then you need to do the classification. And the classification is your optical mosaic is the one that you are going to use now and do the classification. And there's a whole lot of steps. I do not include that one here because it's going to take a lot of time. But at the end of the day, you will come to have the same, in the same area of interest, you will come to have, I could not finish loading this one due to the internet connection. But this is the end result. When you do your classification, you can see this green, because I choose green for the mangroves, and I choose black for the rest of others. So it would have shown, but because of the internet, it could not show the mangrove area. Like I said, it loaded for almost 1.5 hours, and it could not come. So I have to screenshot what I have. So with this, you will have like what you have in Google Earth Engine. But the difference is Google Earth Engine will give you the opportunity to go detail and know some of the data, the information that you might need. That is the height, the above ground biomass, and all those stuff. So I think that is the end. Somebody is telling me that I have gone beyond my time, but this is the end. So thank you so much.